Good morning to everyone. Today I am going to discuss about PNPN diode. It is also called as pin diode and SCR, silicon controlled rectifier. Here, firstly, I am going to discuss about PNPN diode. So here, let us see the basic structure of the PNPN diode, and also it is called as Shockley diode. Why the name is given as Shockley diode? Because of it is the scientist name. Here, this is the construction of this particular PN diode. Let us observe this structure here. It consists of four layers, such as P, N, P, N. Totally, it consists of four layers. And one more point you have to observe here, that is nothing but three junctions. Junction 1, Junction 2, Junction 3. And it consists of two terminals, such as anode and cathode. This is anode. And this is the logic symbols or logic symbol of the PNPN diode, or it is pin diode. This is the logic symbol, one of the type of logic symbol, anode and cathode. This is also both are nothing but PNPN diodes. It is the anode here. This is the cathode. Both are same here. Both symbols are same. Okay. So coming to this here, the first point is it is a four-layer PNPN silicon diode with two terminals. When an external voltage is applied to the device in such a way, the anode is positive with respect to cathode. So then junction 1 and junction 3 are forward biased and junction 2 is reverse biased. So let us see the external voltage here. I am going to apply here. This is a positive terminal and negative terminal. The negative terminal is going to apply here at cathode. Okay. This is a voltage here. VDC, external DC voltage. Okay. So this external DC voltage will be applied here. Okay. So when this voltage will go into the this PNPN diode, see here, this is the positive terminal. The positive terminal given to the positive side of this particular PNPN diode, and the negative terminal is given to the negative side of the terminal. It is nothing but cathode. So let us see here. This is the positive terminal. This is the negative here. Here positive. Here it is negative. Here it is positive. Here it is negative. So at this junction, here it is positive. At junction 3, here it is positive. Here it is negative. At junction 2, here it is positive. Here it is negative. And junction 1, here it is positive. Here it is negative. So for this, at junction 3, it is the P-type region here. It is positively charged area. For positive charge area, we are making here it is a positive terminal, positive signal here, and it is the N-type layer. It is having negatively charged area. For negatively charged area, we are represented with the negative. Then it is the junction J3 is going into forward bias. Okay, forward bias. Okay. Similarly, at junction 1, it is P is the positive here, N is the negative. For negative, here we are making the negative terminal. For positive, it is a positive form here. So again, the junction 1 also in forward bias. But coming to the junction 2, it is reverse bias. Okay. So how it is comes into reverse bias? Let us see here. So it is the negative charge area. It is the positive charge area. For negative charge area, we are applying here it is a positive symbol. Here for positive charge area, here we are giving as a negative symbol. So the junction J2 is in reverse bias condition. Okay. So now the current flowing through the device, the current flowing through this junction, it is only call it as reverse saturation current. So let us see the point here. First point here, it is a 4-layer PNPN silicon diode device with the two terminals such as anode and cathode. Okay? And the next point is when an external voltage is applied to the device in such a way that is anode is positive with respect to the cathode. So then junction 1 and junction 3 are forward bias and junction 2 is reverse bias. Okay? Like this. By applying this forward bias voltage, junction 3 and junction 1 are in forward bias condition and junction 2 is in reverse bias condition. Okay? Next. Then the applied voltage appears across the reverse biased junction J2. Now the current flow through the device is only reverse saturation current. Okay? The current through the device is only reverse saturation current. However, here I am going to discuss about the first point here it is as the supplied voltage is increases, the current also increases slowly until so-called firing or breakdown voltage is reached. Okay, so here by increasing this voltage, okay, the firing takes place across a junction J2 or breakover voltage or the breakover voltage is across the junction to reach whatever the voltage here we are applying. This voltage will be going to increase. Then only at the junction there is a firing takes place across the junction or it reaches to the breakover voltage. Okay. Then once the firing takes place, the current increases abruptly. Okay, and the voltage drop across the device reduce sharply. So at this point, diode switch off to on. Okay, so coming to this condition here, again, by applying this reverse bias forward bias voltage here, forward bias voltage, here junction J2 is reverse bias means the diode here it is act as reverse bias condition. So it is off. Okay, by increasing this voltage, there is a number of large number of minority carriers are released across the junction, and due to that, it takes fires or it reaches to the breakover voltage, then the current will be suddenly increases. So here there is a sudden change in occurs in the current and the voltage is dropped across the junction. Okay. So now here, let us see here the graph here. So this up to this region nothing but the diode is in off and also call it as the region is forward blocking the region. Okay. And next point is once the device is fired into conduction and a minimum amount of current is knowing holding current that is IH is required to flow to keep the device on stage. So let us see this here. Okay, let us see here. Here we are applying the forward bias voltage across the PNPN diode. Here, this is the forward bias voltage applied this particular PNPN diode. Positive terminal given to the positive side, that is anode. Negative terminal given to the negative side, that is cathode. So for this voltage, the junction J3, J1 are in forward bias condition and J2 is reverse bias condition. Due to this reverse bias condition, the diode is going to off. When all the junctions are going to forward bias condition, then only the device is going to on. But it is not occur here because of here J2 is going to reverse bias condition. So by increasing this voltage, there is a slight amount of voltage will be increased as that voltage will be shown here. So this is the current here. This current will be increases by increasing the forward bias voltage. Due to that forward bias voltage, the current will be increases. Okay, if your voltage will be going in increasing order, their firing takes place across the junction 2 or it reaches to the breakover voltage, there the current will be suddenly abrupt to hold current. Now the junction it shorted. Mean the PNPN junction diode is going into on. Okay, here it is act as a off. In this region, it is act as off condition. So now the diode is comes from off condition to on condition. Now the current is going to start in linear way. So here when the current is suddenly absorbed and it is hold at some point, this point here it is represented with the IH. It is called as holding current. And further it is going to increasing. Now the diode is going to on condition because of we are giving the forward bias voltage. Due to this forward bias voltage will be going to increasing order. The diode is going to on condition, means it is forward bias condition. Then the current will be slowly going to increasing order. Okay. So whereas the reverse bias condition here, suppose here we can apply the reverse bias condition like this. Okay, then what happened? The junction J3 and junction J1 are in reverse bias condition and junction J2 is in forward bias condition. So due to that reverse bias condition, the current is going like this. So this is the way. So this current is nothing but leakage current. So here you call it as in this region, that is reverse leakage voltage or reverse leakage current. Okay, reverse leakage current. Here at anode we are make a connection with the negative terminal. For cathode we are making with a positive terminal. Then the diode is going to reverse bias condition. Right? Here I am going to discuss about one more device. It is silicon controlled rectifier. It is also having similar fashion, that is one is the anode terminal and other is the cathode terminal, and the one more terminal is here available, that is nothing but gate terminal. It is also having four layers PNPN and three junctions J1, J2, J3. This is the structure of the silicon controlled rectifier and this is the logic symbol of the silicon controlled rectifier. It consists of three terminals and three junctions and four layers. Let us see here the first one. It is a silicon semiconductor material diode. It consists of four layers of semiconductor materials. Okay, these are the four layers. Okay, next it is having three terminals such as anode, cathode, and one more terminal, it is gate. Now I'm going to discuss about the working condition of this particular silicon control rectifier. So here, for the operation of or for the working condition of silicon control rectifier, here it is going to operate in three modes, such as one is forward blocking mode, and second one is forward connecting mode, and third one is reverse blocking mode. Okay, here this is the forward blocking mode. Okay, now see here. Let us understand the blocking mode. Before going to the blocking mode, we need to go with the junctions. Three junctions J1, J2, J3 are in forward bias condition. If all the junctions are in forward bias conduction, if all the junctions are in forward bias condition, then only the SCR is going to should conduct. So for the conduction of SCR, we need all the junctions should be in forward bias condition. Then only the junction is going to, sorry, the SCR is going to on condition. If any one of the junction is going reverse bias, the SCR is in off condition. So we need to maintain all the junctions, whatever in this device, those junctions are in forward bias condition. Then only the SCR is going to on. Okay. Here, the first one is forward blocking mode. So let us see here. This is the four-layer PNPN, PN, and PN. Here, junction 1, junction 2, and junction 3. Here, we are making initially it is a forward bias condition, forward bias. Okay, and it is a negative terminal here, it is a positive terminal here. Okay, for positive terminal, we are making to the positive area, it is anode, and the negative terminal make here the cathode, it is the negative area, it is N. So then the device is going to reverse bias condition, or it is going to off condition. How it is going to off condition? Because of here junction 2 is reverse bias. Junction 1 and junction 3 are in forward bias. Let us see here the positive terminal here. So this is the positive side, negative and positive and negative and positive and negative. So due to these polarities here, so this junction is going to forward bias condition, and due to the plus minus here, plus is given to this positive p type material, minus is given to the negative terminal, negative that is n type material, then J3 is going to forward bias condition. But coming to the junction 2, the positive polarity is given to the n-type material. Here majority charge carriers are electron, such as negative charged particle. So this is nothing but negative charge area. For negative charge area, we are applying the positive terminal. Here it is positive charge area. For positive charge area, we are applying the negative terminal. So junction 2 is in reverse bias condition. Means there is a small amount of charge carriers are moving from through this junction. Due to that, there is a slight amount of current will be going to flowing. And this region nothing but depletion region. Okay, let us see here the forward blocking mode. In this case, positive terminal is connected to the anode and negative terminal connected to the cathode. So the junction J1 and J3 are in forward bias and J2 is reverse bias. Hence, the SCR will not conduct. So means it is in off mode. It is in off. Okay, but let us see here. Here we are applying the positive voltage, that is forward bias voltage, but here the SCR is going to off condition, means it is forward blocking mode. Actually, we know if you are applying the forward bias voltage for the particular P and N type of material junction diode, then there is a movement of charge carriers. The charge carriers are nothing but majority charge carriers. Means there is we are expecting there is a current. That current is due to the majority charge carrier current. It is practically considered. But here there is a opposite case. By applying this forward bias voltage, this PNPN, nothing but SCR is going to off condition. Why? Because here all the junctions are not in forward bias condition. Here only junction 1 and junction 3 are in forward bias, but here junction 2 is reverse bias. Due to that, this device is off mode. So the SCR will not conduct. Right? Next. So further increasing forward bias voltage, then the small current flows and the current is not increasing till increasing the voltage. It is called forward blocking mode. Right? Next. And next one is forward conducting mode. And this is our diagram here. Forward conducting mode. Forward conducting mode means here the SCR is going to on. How it is going to on condition? Let us observe the conditions. Here it is a forward bias voltage, right? So the positive terminal, here it is a negative terminal. The negative terminal given to the cathode, the positive terminal given to the anode. And one more terminal, it is the gate terminal. For gate terminal, we are applying here, it is a positive terminal and it is a negative terminal, right? So here, so by applying this voltage here, it is the positive and it is the negative. Okay, here this is maintaining, it is a positive terminal, it is the negative. By this voltage here, it is the negative and this one is the positive. So by applying this gate voltage, junction J2 is going into forward bias condition, and by applying this voltage J1 is forward bias condition, J3 is also forward bias condition. Now all the junctions are in forward bias. So the SCR is here, it is on condition. As I told you, we need to maintain all the junctions are in forward bias condition, then only the SCR is going to on. Okay, let us see the points here. In this case or in this mode, the anode and cathode are in forward biased condition, but here we apply one more voltage that is in between gate and cathode. Here the positive terminal is towards the anode and negative terminal towards the cathode. So this will make the junction, which is reverse bias junction J2, comes into forward bias. So here we keep positive at anode and negative at cathode. So all the junctions in forward bias such as J1, J2 and J3. So the SCR is now conduct and forward voltage is drops. The forward voltage drop and the SCR starts conducting the current linearly. This is known as forward conducting mode, right? So here let us observe the one more point here. The important point here it is forward voltage is drop, right? So here by increasing this voltage here, that is forward voltage in between anode and cathode, the device is going to a junction 1 and junction 3 and forward bias condition, and due to this gate voltage the junction 2 is also in forward bias condition. It is also in increasing order and it is also in increasing order. Okay, but at a certain point this voltage will suddenly decreases across the junction, right, by increasing this voltage. And third point, it is the reverse blocking mode. So in this case, let us see the diagram here. The gate terminals act as open circuit, and here the negative terminal given to the positive, and positive terminal given to the negative. Then this third is going to working as a reverse bias. Why? Because J1 is act as reverse bias condition, J3 is act as reverse bias condition, but J2 is forward bias condition. Let us see the polarities here. It is minus, it is plus, it is minus, it is plus, it is minus, it is plus. For negative terminal, we are given it as a negative, positive. For positive terminal, here we are maintaining the negative. And here at the junction, For positive, we are making positive. For N is negative. Now, due to this, here J2 is forward bias. And this one polarity is here at J1, it is reverse bias condition. It is only forward bias. Right? Okay. So here only J2 is in forward bias condition. Let us see here. In this case, negative terminal is connected to anode and positive terminal is connected to the cathode. Then J1 is reverse bias condition, J2 is forward bias condition, J3 is reverse bias condition. So a small current flows, but it is independent of applied voltage. But it is independent of applied voltage. So increase the VR and it will allow above the permissible level. Then the junction breakdown occurs and current flow large. This is the reverse blocking mode, right? So let us see the VA characteristics of this SCR, silicon controlled rectifier. So let us comes into this forward blocking mode. Here junction J1 is forward bias and junction J3 is forward bias, but here junction J2 is reverse bias. So means by applying the positive voltage, positive forward bias voltage, okay, it is given to the anode, it is given for cathode. So then the junction J1 is forward bias and junction J3 is forward bias, junction J2 is reverse bias. So due to the reverse bias condition, the diode that is nothing but it is a SCR. SCR is going to off condition. Means here very small amount of current is flowing, that is because of junction J2 is reverse bias condition. So this current is nothing but this is the current. So in this way, okay, this is nothing but forward leakage current. This is the current here, forward leakage current. And the second case, it is the forward conduction region. At that case, the junction J2 is going into forward bias condition by applying the gate voltage. By applying the gate voltage. So this gate voltage makes the junction J2 is also in forward bias condition. So by increasing this gate voltage, then the current will be suddenly abrupt. It is comes into here. Now the SCR is going into increases. Suddenly the current having abrupt to change from A to B and same at the same time the voltage drop across this junction is decreases. So this voltage will be decreases. Okay. Now the SCR is going to on condition till you have to maintain the voltage in increasing order. Then the current will be going into in linear position from B to C. Right. Similarly, in reverse bias condition, a negative voltage like this here, negative potential is applied to the anode and positive potential is applied to the cathode. Here negative potential applied to the anode. Then the junction J1 is reverse bias and junction J2 is forward bias and junction J3 is reverse bias. Okay. By applying this voltage, there is a flow of charge carriers across a junction. Okay. Then that current is nothing but reverse saturation current, that is reverse leakage current. By increasing this voltage, then automatically it overs the breakdown voltage. Then the current will be going in this way, that is E to F. So this case is nothing but reverse breakdown voltage. Totally, this region is nothing but reverse blocking region. Okay, this is the VA characteristics of SCR, right?